Right. So I'm just going to go over the review that is already there because honestly, the exam is same as that. Like the questions and it's just a different data set. So if you know how to do this review, you should be able to do the exam. Um, so I'm just going to go over that again, and then obviously you guys can ask questions. So for the review, I have opened the weekend review key, which is available online in the in-class practice, and then the questions are also available here. Uh, share my screen. Actually. Yeah.
Now that the exam is open book, but like how's that work?
Honestly, you don't need open. I mean, like you can bring a book. Um, I don't think so. You need an open book. Um, because there's no. I mean, like there might be conceptual questions as there were in the review. Like explain something like confidence interval or something. Maybe you can use it for that, but I don't. I don't know. Like, yeah, I don't see the need to honestly look at the book. Yeah.
But we're allowed to have like a cheat sheet though, right? Like what which codes to use, because I don't know if it was you who sent it or Dr. G said that we could have a cheat sheet.
I didn't send it. I think Dr. G. Yeah, I mean, like if he sent it, then yeah.
Some classes are very specific on like one page, how to,
Mm,
what, yeah.
honestly, I don't know. He didn't mention any rules. Like, did he send an email for that?
There was an announcement in Canvas. That's really great.
Yeah, just said you can bring a cheat sheet, but it didn't have any.
Yeah, I think like one page, two-sided. Usually that's how it works. I think like yeah. Because you're already allowed to have a book open. So I don't know, like yeah, yeah, just one page. And yeah, it could have like some formulas or something. Yeah. Um, but honestly, like I don't there's nothing like you need to know Excel. I mean, that's it. Like, there's no way around it. Like, you need to know Excel and how to use it for what we've been covering in the class. Because, like, other than that, there are very few conceptual questions. They're very basic. Like, okay, what's confidence interval? Like, what is this coefficient mean or something like that? Yeah,
Okay.
have the whole. Yeah, it's like 2.5 hours. So you get there at 9, and then you can look at the questions and for the first 15 minutes. And then I think we start at 9:15 or 9:30 and then goes till the end. Yeah. Okay. Uh, data here. Yeah. So I'm going to just going to be using the data here, which is I've opened the key part. If you want to open, you can just open the simple VK so you don't look at the key and you can work alongside. It's up to you. Uh, and so the data originally, um, let's see. So the data looks like this, the untidy format. Um, we won't be asking you to tidy the data, like just in the review, like there's some exercise where you just give, okay, what the tidy data should look like. The tidy data would be provided. So, but just know like how to tidy a data like this, which has like, like countries and then indicator names. And you should know like which variable, like these should be variables instead of like values. So I think the question also here is, okay, so number of observations, number of rows, number of columns, and the unit of analysis. So That's number of rows. You just uh, put the formula rows and then give the whole range. So you see here, these are all the rows. So you want to cover all the rows that you want to do. So you can select all the rows all the way till down, and you can do that by Control Shift and down key, and it will go till the end. And once you put that, so there are 642 rows. And then similarly for the columns, here you can do columns and go back to the data. And then columns are horizontally. So you select the first column and then you can do Control Shift right, and it will go till the end. Uh,
So this is from the data tab, not the tidy data set, right? That would give these one.
yeah, this is the original data.
Okay.
Yeah. And so these are the columns. Um, Also, one thing, if you are going to use Control Shift down, it's going to go till the next uh, cell that is not filled, right? So beware of that. Like if you're trying to find the number of rows, make sure that there are no missing values here. Otherwise, you can just manually select the data. Because if you think that, so it's always safe to do that. But I know that this column is not missing, or either select a column which has no missing values, so that you can find all the number of rows. Otherwise, if you're trying to find number of rows from this column and you select Control Shift down, it's going to go, and then you'll have to you continue doing it manually till you get to the end. So yeah, just be mindful of that. Okay. And unit of analysis, basically, it's the the unit that you're doing your analysis in, and it's basically for these variables because we know that these indicator names, they have some units. Uh, so at the first unit, you have the countries. So these are the variables. So their unit is, like this, the country name or country code. And then these indicator names, which would essentially become your variables or features. What are their units? So GDP, so the units for GDP is US dollars, life expectancy is number of years, and then poverty headcount ratio is percentage of population. So you are basically giving the units of all the variables which have units. So in this case, one of the variable is the country. So the units is just the country name. And then the other variable, so you need to be aware of what are the variables in this data set. So even though this right now the indicator name, these three are not variable, these are values, but you know that in tidy data set they will be values. They'll be variables, right? So you have to give their units. Um, yeah, and then years is just years. Um, Okay. Are there any missing values? How many indicate the result as a single number and as a percentage of total number of values? So, you're trying to find the number of missing values, and the way you can do is you can use count blank, and it's going to give you all the cells where there's no value, and those are essentially the missing values. So what you can do is you can use this count blank, and then you give it the range where you want to find all the blanks, right? So you want the whole data set. Uh, you want the whole data set. So, okay. So you want to select all the columns and all the rows all the way down. right? Um, oh, oh, sorry. Yeah. So for missing values, you don't need to do these country name and indicator code because these are not your values. These are not the values you're looking for. You're only looking for the values here, which start here from the years, right? So you're calculating, counting all the values. Uh, so it's important to recognize what range of values you're looking for. So these are just the variable names, right? So you're not interested in these as values and they're already filled. You want to find the missing values in these columns, which actually correspond to like GDP values or uh, uh, life expectancy. So you will select all these 10 columns and then uh, select all the way till the bottom. And it's going to give you the count blank values for for that range. Just check it again. Mm, yeah. Um, and so once you get that, it's asking you to find the total number of values. So if you do the count blank, it's going to give you only the blank values. And if you do the count, it's going to give you all the values which are not blank. It's not going to give you all the values. It's only going to give you the values which are not blank. So if you do count blank, it's going to give you the blank values. But if you do count, so the next step is you want to do a count to get the values which are already there, right? So you just use count and you give it the data from as the same range as you used for the count blank, E1 to N642 or oh, it should be 643. Sorry, my bad. This should be 643. And then, so you do the same thing with the count. Um, and this should be E2 because you don't want the headers in, right? If you do, yeah. So you give the same, you use count and then give the same range. So there are 2106 values there, which are blank, and then 4314 values, which are not blank. So the total number of values is just the sum of these two, which are 6420. So you just sum both these values up and you get the total. And then you can represent the missing values as a percentage of total values, just 2106 divided by 6420, and you'll get the 32.8% of the values are missing. Everyone following? Good. Okay. Right. Yeah. So then which of the following options would you consider to fix the problem? Now, there's no one correct answer for this question. Um, so imputation is when you sort of estimate a missing value. When you look at the values and when these values are missing, you can estimate those values. So let's say if there are 10 values um, for life expectancy, um, there are, someone has a country has 20 um, from 2013 to 14, 15, 16, and all the way to 21, right? And they have some life expectancy value, like let's say 60, they had 60 and then 61, and then every year it increases by 1 year. And so you go all the way down, and then somewhere here, like you have a life expectancy of 70, right? So imputation means that maybe you have all these values, but for 2019, the value is missing, right? So one thing you can do imputation is that you can guess this value. And there are multiple ways to do it. You don't need to know how to do it because you're not required for this course, but I just explaining what imputation means. So you can do what you can do is you can do you can see, okay, there's a pattern every year the life expectancy increasing by one and it continues even after 2019. So you can guess it, okay, like maybe most probably the life expectancy if the upper value is like 67 and the next is 69, then it's 68, right? In other cases, there might not be a pattern, but you might want to take an average, and that fills in the missing value. Or sometimes you even run regression. So imputation is that. There are two ways to deal with missing data. One is imputation. You guess that value through some method, through taking average or sequence or regression. And the other method is just dropping that data, uh, dropping that dropping that row wherever the data is missing. And it's a choice that you have to make based on certain factors. If there is, like if your data looks like this and only one value is missing in a year, maybe you can guess it. But if your data looks like all these values are missing, and then maybe like one value is here and then this value is here, then you don't have enough data to guess it. So then the best course of action would be most probably dropping the values. So you have to look at the data. So in this case, if you look at the data, you can see that the the life expectancy data is pretty wait, sorry, life expectancy or yeah, the life expectancy data, it's pretty well populated in the sense that, like it's missing for 2021 for certain countries. Uh, I think for all countries it's missing 2021. Yeah. So, and the other thing is like if the value is missing for one entire column, then you can just probably drop that column. Like, if the life expectancy is given for all these years 2013 to 2021, and then this one year, all the countries or majority of the countries are missing that values. So you just can drop that column instead of, deleting the rows. But if you come to the poverty head count, it's not well populated, right? It's like this like Afghanistan only 2020 one year has that value. And then for other countries. So in that case, you might want to either drop that column altogether or drop the rows or like because there's not enough data to work with or you can see okay if the values are available for one year like let's say 2016 most of the countries have the value for 2016 so you can just do an analysis on 2016 for that particular variable so it's a choice that you make um and also like if imputation works when less than a certain percentage of data is missing. So if your data set is missing like 50% of the data or maybe like even 30% in this case 30% is missing, then imputation might not be a very good option. You might want to drop that column or those rows. But if your data is missing like 10% of the values, then maybe you can impute because you have enough rest of the data to like guess those values. So yeah, so like if missing one, two observations, you impute. But if the majority are not available, then you just drop that variable. Okay. Which of the following? Okay, so is there any redundant information? If not, explain why the information is not redundant. So yeah, like our data set has um redundant information in like this indicator name and indicator code, and then country name and country code. You just need one of them, right? It's giving the same information. So you can keep either country code or country name, and you can keep the indicator name or the indicator code. So that this is sort of like redundant information. Okay. And then, so why is the data not tidy? So we've covered this. A tidy data has um, variables not as values and values not as variables. So in this case, you know that our data has these indicator names, the GDP and life expectancy and poverty headcount ratio as values, and this is a long form of data. Sorry, this is wide form of data, and special and then again like these values, the years which should be values are variables. So that is why the data is not tidy. So you want to convert it into a format where variables are in columns and then values are in rows, and it will become long form then. So right now it is wide form, it is wider. The tidy data would in most cases would be long form, so it would be longer and not wider. Okay, and then so you go to the tidy practice sheet here, and so the tidy practice sheet, I've opened the week 8, not the key, just the normal week 8 sheet, so I can fill it. So what it's asking for you is that this is the untidy format given data. Just fill in these values here for GDP, poverty, and life expectancy to make this tidy. So you should know how to do this. Like, I think in the exam also, you'll just be asked to do this like small demo for like, how to tidy the data and not the entire data because it takes a lot of time. But you should know how to do it because it's going to be asked. Um, and the way you want to do is, I don't want to see it done manually. Like you can literally pick one of values and copy paste it. I want to see like some formula for that, like VLOOKUP or index match or something. So let's say if you're doing the GDP, um, you can do VLOOKUP here. So the lookup value is you can use the country name, and then the table array. So you can give this entire table. So you're just doing the GDP right now, right? So you just pick the GDP rows and the column index number. So you've given this whole data array, and you want the values for 2012, right? So because you want 2012, so you'll calculate the number of the column which is 2012. So 1, 2, 3, 4, 5. So number fifth column, and you want a false because you want exact match. So it's going to give you the GDP value, and you can just drag this down, right? And you can repeat the formula again here. So you can use the same formula like this one, but this time you want the value from 2013. So you'll just change the column from 5 to number 6, and this will give you the value. And then you can drag and drop till 2013, and then do the same for, and when you're doing poverty, this time you select so you can use this formula. And instead of the from A1 to N4, so for these first 4 rows, you select the next 3 rows. So you can do A5 till um, from A5 till N7, right? So because you just need the life expectancy now. And for the first one, you need 2012, so it will be the fifth column. And then you can drag and drop for the first 3 values. And then similarly again. So do you get that? So when you're doing this, don't do it manually, please. Don't like copy paste values because you won't get the credit. I want to see VLOOKUP. I want you to know how to use VLOOKUP and um, just show me. And if you like, if you can show me like the first 2 rows or the first 2 columns, and then the rest you want to fill manually, just write it, okay. So I know, okay, you know the formula, you just don't want to spend a lot of time on that. But at least show me at least 2 rows, 2 different indicators or 2 different columns fully filled. So I know you know the formula, how to change the formula accordingly when you want a different variable or you want a different indicator, or you are at a different country row level. Uh, yeah. So once you fill that, so it just asks you for that, and the exam would be very similar also, like, just knowing how to make this tidy sheet. And then, oh yeah, one thing I think, so with the poverty rate, sorry, let me go back. So so where you have this issue of having missing values, um, you can you can fill in that missing value with something to indicate that it's missing instead of leaving it blank. You can put an NA or you can put in a dot. And so the way you do it is when you're applying the VLOOKUP formula. So if you look up here, when you're applying the VLOOKUP formula, sorry, you want to apply some conditions. So first condition is your if, and it's going to check. So your first condition is if, and then your logical test is what do you want to check? So you want to check if the value is missing or not. And you can see here in poverty head count that the value is either a number or it is blank. So the first test is, can you check if number? Now, if number is true, then you want to apply a VLOOKUP. And for that VLOOKUP, you are putting the whole, the formula for VLOOKUP again, and then you do lookup value as this country, and then you give the range for the poverty head count, so last 3 rows, right? And you are checking for the fifth column, and then true, sorry, false. Now, the So, I had written this part of the formula. So what it's doing is that this part is just, it is checking for is number, right? Now, if it is a number, then it goes to the, then it goes to this condition. If so, if it is a number, when it VLOOKUPs and it says, okay, it is a number, is number. If that is true, then you want it to input that number value, right? So you can just do the VLOOKUP again because now you are putting in the value for that VLOOKUP. So you can just repeat this whole formula. And if that condition is not true, then you can put in a dot. Hmm. Oh, yeah. Yeah. So, sorry, this should be in poverty. This should be other way around. Not life expectancy. Uh, yeah, the formula should be other way around. So it should be life expectancy. It should be poverty. Yeah. So you see here that the first, for all these countries, the poverty, it should pick a value for 14. Sorry. So you see here for 2012, only Afghanistan has a poverty headcount value and the rest two are missing. So that is why you get these two dots here. Uh, everyone following? Okay. Good. Uh, okay. And then the next is you do a code book. So you're already given this code book in this format. So you just need to fill this in and so in the key, it is filled, but basically the variables are given. So you give it their description and then the type of variable. So country is a categorical variable, so it is a nominal variable. And then here is interval because it has set intervals, one year intervals. GDP is continuous because you have this variable which can take any value and it has decimals. Life expectancy similar is continuous. It can take any number and up to decimal places. And then similarly poverty also. And then the unit of measurement, country doesn't have a unit of measurement. Obviously, it's a nominal variable. Year has it's a number, it's an interval, so it has a unit of measurement, years or calendar years. And then the units for GDP, USD, life expectancy years, and poverty percentage. Okay, so then uh, so um, we're going to do summary statistics, so exploratory analysis for the last 10 years. So once you have so this is what you want your summary analysis in. So you have a country, you have the minimum of the GDP, maximum of the GDP, average of GDP, standard deviation of GDP, and then count of GDP, right? So this is what the format you want your summary statistics to be in. And this is again an exam, you'd be given this sheet, so you know what format you want to do it in. Um, and the way to do it is once you have the tidy data, so you have the tidy data here. Let me remove the filters. So you have the tidy data here. So you are now building a summary sheet from this tidy data. So you can insert a pivot table. So go to insert and pivot table from, oh, wait, sorry. Yeah, so it's already selected the entire table. You can either select them manually first or insert pivot table and it will select all the data in that sheet. So you want a new worksheet for it. So once you get this pivot table, so what do you want? You want a country in your rows. So you have all these country. Actually, let's do country name, right? Uh, and then you want the minimum maximum uh for GDP. Um, so you can have so you put GDP in values, and when you do that, it's going to automatically do a sum of GDP. You don't want a sum. You want a minimum. So if you open this and go to value field settings, you can choose different options. So you want a minimum right now. So you do minimum. Again, drop GDP here, and this time you want a maximum, and you can repeat this for different values. So you have a minimum, maximum. Now you can have the average, and you can have the standard deviation, and then finally you can have the count. So this is what the summary statistics need to look like, right? And you can do that and just repeat it for life expectancy and the poverty rate. Charger. Yeah, so just once you have that, repeat it for the life expectancy and poverty rate, and then you can also like the fix this data to make it more um, readable, I guess. You can convert it into currency and keep it to two decimal places, right? So once you have this summary sheet, it should look like this. Minimum of GDP, maximum of GDP, average, standard deviation, count. Same thing for life expectancy, and then same thing for poverty. So once you have this summary statistics, it's much easier to do an analysis on it, which we are going to do. So what is the country with the smallest average GDP, percentage poverty and life expectancy for the last 10 years? So once you have that, um you want to find the country with the smallest average of these three variables. So the way you do it is once you have these summary statistics, if you go here if you select this sort option and go to more sort options, it's going to give you this pop-up. And right now, the sorting is done by country name, which is your row labels or the first column. But you want to change it to, so you want to find the average, sorted by average of GDP, because you want to find the smallest, right? So if you do average of GDP and click OK here, it's going to sort by the average of GDP here. Yes.
Sorry, I was still mentioning that thing.
Yep. So if you go to this option here, row labels sort, do you see this arrow? So you click on this arrow and do more sort options. And right now it would be automatically selected for the country name. But you want the average of GDP. So select average of GDP and you want to keep it in ascending order and you do that. So Kiribati has the smallest average GDP of $182 million.
Thank you.
Right? The next thing you want to do is sorted by average of life expectancy. So you get the country with the smallest shortest life expectancy, which is Central African Republic, which is a life expectancy of 51 years on average. That's the smallest. And then similarly, you sort by um, poverty, average of poverty, and Ukraine has the lowest poverty rate, average poverty rate for the last 10 years. So you're just sorting and finding the answers to these questions. Okay. Round the average life expectancy to 0 decimals and build a frequency table for the life expectancy in years. So when you go to the summary table here, and let's just remove I just sorted by country name again. So you have this life expectancy. So what you can do is you can select this life expectancy column, and copy paste all of it except for the grand total at the end. Don't copy paste that because that's just average of all values or whatever. So select all the values up till Zimbabwe, which is the last country. And so the sheet is open here. So if you copy paste it, uh, actually copy paste it as values. So this is already rounded to no decimal places, but you might copy and you might see some decimal places. So you can just round it if you do average life expectancy here. So I'll just show you. If you see these values here, and oh, this is minimum. Sorry, my bad. Sorry, I copied the wrong. I have to do average life expectancy. Yeah, so copy paste this. This. So if you select this column, then so this is what it looks like. If you copy paste it, your values might look like this or even more decimal places, right? So you just need to round this to 2. So you can create another column here, round, and then for rounding something, you use the round. And the round formula takes two inputs, the value that you want to round, and then how many decimal places you want to round it to. So if you do this to 0 decimal places, it will round it to 64. So once you have that, then you can build a frequency table from it. And the way you do it is you can select this data and then insert pivot table. And on the existing, oh, sorry, you want to give it a location here. Let's delete this. Yeah. So just select this data and then insert pivot table. And then we want to put it here. Let's put it here. So once you have that, you just want to build a frequency table. So the way you do it is you put these values as rows and you can put these values as put it as values also. And it's going to give you and you can select count here. So for each value, it's going to give you the count. So how many countries have average life expectancy of 51 years? How many countries have 52 years? And then you can also sort it by the count here. So instead of the average life expectancy, you can do it by count. And let's do descending, sorry, and do it by count. So most countries have an average life expectancy of 76 years. So that is the mode of your distribution, because mode is the most frequent observation. So 76 years, that is the mode. And what is the percentile for the life expectancy for the US, Chile, and China? So once you have that frequency table, you can use it to calculate percentile of any country. Um, you don't need the frequency table for it, honestly. You can apply the formula, which I'm going to apply because like frequency table, you might have to do it manually, like finding the percentile, which is, you don't need that. Um, but the way you can do it is, um, did I ask to create a frequency? Oh, sorry. Yeah, so for the percentile, what you can do is, there's the formula called percentrank.inc. Uh, And the way you do it is if you use this formula, so if you write percent rank dot inc, it's going to take two inputs. right? So your first input is the array or the range of values that you want to take the percentile from. So if you go to the summary table, um, and you want it percentile for the average life expectancy. So you give it the all these values for the average life expectancy, right? Um, and the other is you want to find the life expectancy for the percent rank for United States, which is the Oh yeah, sorry. So you give it the all the range of the values for every life expectancy, and you want the percent rank for the US value, right? So you go to the summary and you pick the US value, right? So you go to the US, you don't pick its name, sorry. And you go, so you see US here. Um, you want the value for a percent rank for its average life expectancy here. So this value, 79. Yeah. So it's going to give you the percent rank. Yeah, so you can do the same thing with the chili. So put in the same formula, percent rank dot int, and then give it the array here for life expectancy, all the values, and then for the value for chili is I-37. Oh, okay. You can pick the value for chili here. Uh, this, and 82%, 0.6%. The values might not match because I think when I did this, I was using these values, these rounded values, but I think the right way to do is not use rounded values, use the exact values. So yeah, but even if you do the rounded values, as long as the answers make sense, you know the formula, then it's fine. Um, okay. What else? Round the average poverty to zero decimals, create a histogram for the distribution of average poverty for the last 10 years for countries where an average is available. Use a bin interval of 5% and consider a range from 0% to 90%. Um, so if you go here, um, the poverty rate, um, the average poverty rate, uh, wherever average poverty rate is available. So if you copy paste all these values for poverty, um, yeah,
For the doctor, right, because like the hashtag div/0.
yeah, that's what I'm showing. Right.
Okay, so just might put it to them.
Yeah. It's in mine also. So if you do paste as values, so this is your average poverty, right? So what you can do is apply a filter here on this column. Where did the filter go? Okay, data filter, right? And then you can you can select all the values except for this div 0, right? Because you don't want to include that. And then you can just, literally copy paste these values and here paste again as values. So this time you'll just have the all the values uh, except for the div 0. And then I think in the question it asked to zero decimals, right? Yeah. So we can do average poverty round. And then again, you can use the formula round. And then go all the way. So this is your rounded values. And then it says you can create a bin of 5% interval and consider a range from 0 to 9%. So with the way you create bins is you can write bins here and you can start with your uh, so the first bin is 0 to 5%, right? So the end point is 5. So you'll keep doing that 5, 10, 15. And once you give these values, if you select these 10 and 15 together, Excel knows that you are adding 5. So if you drag it all the way down, it's going to keep adding fives, increments of fives, and you want to go all the way to 90 because that is where the question asks, right? So these are the bins, and then this is the average poverty round values. And to put the distribution, frequency distribution, um, you do go here and do the histogram.
I can get it to autofill again for the fives. Five.
Okay. Right. So if you put 5 and 10 here, right? Select both of them
Oh, flip it.
and then go at the end and then you can drag all the way down. 90. No worries. Um, Oh, yeah. So to find the frequency, once you have the data in this format, the average poverty in round, and then the bins that you want to create. So the input range. So what you can do is go to the Shore tool pack that we have downloaded in the Excel. So this is why you want to use Excel because you won't find this in Google Sheets. So go on that and select histogram. And for histogram, like you want to get the frequencies, right? So first is input range, the data that you want to put in, and that is all this data that you have for average poverty, right? From B1 to B140, and then the bin range is uh you have the bins here already specified, so you can just select them, and then this should be B2. Don't wanna include the headers.
Can you
And
put the title of it in there too? Or just the value?
not the title. And then the output range, you can select somewhere here, G1. And so, yeah, it's going to give you the bins and the frequency for each bin and the histogram then and the corresponding histogram for it. Let me check. Something. What's happening here? Oh, okay. Makes sense. So if you can see here, the sheet that I created right now, um, this sheet two, um, the frequency chart that I built here, you can see like for the first bin there are like seven observations in the frequency, and if you look at the 2D sheet which I have in the review, you can see that the frequency would be different, and that is because um, the way we have rounded the values. So here we used like not rounded values. We used decimal places, actual decimal places, and didn't round the values. But in this sheet, I rounded the values first. So the way it is, taking those values is different from how the values would look like if you didn't round them. So that can affect, but the question asks to round to zero decimal places. Usually when you're creating bins, you don't round because you already are creating bins, are giving it a range, so it doesn't matter how many decimal places are. But in this case, the question does ask to zero decimal places, so whatever the question asks you that. Um, yeah. So this is what your frequency chart would look like. So there are seven countries which have poverty rate from 0 to 5%, and then seven countries which have poverty rate of between 5 to 10%, and so on and so forth. And so the question asks, like, what is the mode of the distribution? So mode of the distribution is the interval which has the highest frequency. So this 25, it means that it means 20 to 25%, because this 25 means here that this is the upper bound. Uh, so and you have intervals of 5. So everything between 20 to 25%, that is included when it says 25 in a histogram. It is the upper bound. So uh, so 20 to 25% poverty rate is the mode of the distribution. And mode, is the distribution symmetrical, right skewed or left skewed? And so if you look at this distribution here, yeah. So this distribution here, what kind of skew is in this distribution? Can someone tell? Sorry, what?
Right.
Yeah. And with right skewed, what is the relationship between median and mean? Yeah. Yeah. Because there are a lot of values on the right side, right? But like there's some values on the right side, but there are a lot of values on the left side. So median would be pushed to left and the mean would be pushed to right. So that is when mean is higher than the median. Okay. I'm just going to take like a 3, 4 minutes breaks. You guys can also just come back. Yeah. Nina question.
It's it's all research like research and I'll be back on more stress. I remember I saw my opportunity. Carelessly.
Yes.
Yeah, it's not we can ask these is little set up, but something with that mess in my gut. Yeah, because I did this the other day and with these values, when I should copy them over, now it's not letting me create. No, I won't. Yeah, it's trending. Like this is what it's made. Oh. It's weird, like copying these over. Well, I didn't copy probably for that, so I lost it when I copied only summary slides. So I copied from. Yeah, that's what I did, I pasted it down. And then I filtered it and then we copied the filter it, it's still, it doesn't cut it down. If there's like say 100 rows and you filter it, it's still going to say what those values were and you know, they were. Did you round it?
Okay, so um, let's do the next question. So probability, assume that the life expectancy distribution among the countries follows a normal distribution. Using the data from section C, in the previous question, average life expectancy, calculate the average and yeah, so. Oh, sorry.
Oh, filter
Right. So calculate the average and standard deviation for the average life expectancy for um all the countries. So if you go to that sheet here, the which where we have the rounded values. So just calculate the average and standard deviation based on these rounded values, even though this is available here in the summary, but that's for unrounded. So you want to do it for rounded values. So you can just do average and give all the values here till the end.
Second question is information?
Yes. So this is your average, and then the standard deviation is T def. Yeah. And again, you can give all these values. Right. So yeah, you calculate the standard deviation and mean. And then the next question is, if we randomly select a country from the list, what is the probability of selecting a country with an average life expectancy for the last 10 years greater than 75 years? Uh, so for that, um, you can use the formula. So you can use the formula for normal distribution here. Um, so if you do norm distribution, it's going to take a couple of inputs. The first is your actual value that you want to. So it's saying 75. And then your mean here is we calculated it here. Um, where did we calculate that? Yeah, here this mean. So you can pick this mean, and then the standard deviation is here, and then cumulative. Yes, you want cumulative. So this is going to give you the probability of all the values of being less than 75. But the question is asking more than 75. So you can just do one minus here. And this is going to be the percentage. So 35.8%. The answers might vary a little bit because based on if you're using rounded values or not. So don't worry about that. But yeah, so that is your probability distribution function. So whenever you're giving a normal distribution, you can calculate a probability of a value occurring. And this norm distribution will always give you the probability of the left side, which is less than a certain value. So in this case, less than 75 probability. So if it's asking for more than, you just do one minus. Okay, what's question number 4? So hypothesis testing assume that the life expectancy distribution among the countries follows a normal distribution and then all samples have equal variances. Calculate the standard error for the average life expectancy for the last 10 years. So you have the um, standard deviation. And standard error is basically standard deviation divided by square root of the square root of the town. So you can use the formula for that. Your standard deviation, you already calculated it here. 7.79. You can use this value or you can use the value from the summary table. It doesn't really matter. And the values might differ if your place you're rounding or not. In exam, either one would be fine as long as you know the formula and you're applying the right values, like you're picking standard deviation and then dividing it by the square root of count. So your count for life expectancy, you can pick it from the summary here. So 1970. So this is the standard error 0.176. And then provide a 95% confidence interval for the average life expectancy for the last 10 years. So once you have the standard error, you can calculate the um, confidence interval. So for once you have this, sorry, for confidence interval, you don't need standard error for confidence interval. So you can use the formula here. So it's called confidence dot T, and it takes three inputs. First is the confidence percentage. So you want a 95% confidence interval. So the alpha would be 5% or 0.05. And then the standard deviation, you can pick it from here. Um, and then your size is 1970, which you pick from the count. You can manually input or pick it from your pivot table. Um, and so this is your confidence value. And then you can use this confidence value to calculate the confidence interval. So confidence interval is just essentially your um, mean minus the confidence value and mean plus the confidence value. So your mean here was we picked the mean here. This is 72.17, and then minus your this value, confidence value, and then similarly this mean plus the confidence value. So this is your confidence interval, 71.83 to 72.52. And okay, so we have the confidence interval. We want to see if average life expectancy for the last 10 years across all countries is lower than 72.5 years. Um, write the null hypotheses and alternative hypotheses. So it's saying that for the last 10 years, from 2002 to 2011, the life expectancy was 72.5. So is the life expectancy from 2013 to 2021 lower than that value or not? So your null hypothesis is, so you write the your hypothesis. Your null hypothesis is that the average life expectancy for all the countries is not statistically lower than 72.5. So average life expectancy for 2013 to 2021 or 2012 to 2021 is equal to the life expectancy from 2002 to 2011, which is 72.5. And the alternative is that the average life expectancy of all countries is statistically lower. Um, and what kind of test would that be?
I want to,
Why?
because you're only saying below a value,
Yeah.
you're not saying, is it above or below?
Yes, yes. So yeah, two-tailed is when you're interested in both sides. One tail is if you're interested in just one side, either above or either below.
And will the question on the test be clear about whether it's below, above, or?
Yeah, it would, yeah, because
You don't have to.
to formulate the hypothesis, you need to be given it in words, right? That is it below or above, so you know. Um, so once you have that, Stacy, why do I see a puzzling look on your? Okay. Okay. I thought like maybe you're lost. Um, so one tail test. So the data for the previous life expectancy is contained in sheet. Conduct the appropriate hypothesis test. So we have the for C. Yeah. So you have the life expectancy. So for this decade, you copy paste the values. So they're in multiple places. You can pick these values, um, and then paste them as right. And then you can reduce the number of decimals. And then the previous decade is already hypothesized. It's all 72.5 because the mean is 72.5. So once you have these two range of values, then you can do your hypothesis testing. So you select, you go to the tool pack here and what was it? So you do the two t-test. And our question already stated that the variances are equal. So we're going to select equal variances. So two sample test, assuming equal variances. So variable one range is your variable one is this average life expectancy for for our current data. Right. And then the variable two range is for the previous decade. Uh, yeah. And then the hypothesized mean difference is 0. We're assuming it's a difference of 0. And then let's just put the result somewhere here. Once you do that, it's going to give you this table. And the way you can use this table is you look at the one tail p-value. And the one tail p-value here is, something's wrong. Oh no, sorry, I copied the wrong. I copied the averages. Yeah, so if you go to the summary table here, not the summary, the tidy full average life expectancy. So you can pick the life expectancy from here and then just
So
copy.
it has to be the full.
Yeah, it has to be the full day. Yeah, yeah. So my bad. Uh, yeah. And then, so the range should be A1 till, I think it should be, well, 1971, 1971. And then same for the 71. So, damn.
When looking at this, we look at the only the one tail value.
Yeah, you only look at the one tail value. Yeah, not right. Yeah. So you look at the p value of one tail, which is less than 0.05. Um, So what do you do when you're
You
PVAC?
reject null.
Huh?
If it's less than 0.05, you reject null.
Yes. So you reject the null hypothesis and you accept the alternative hypothesis, which means that um your average life expectancy for this decade is lower than statistically significantly lower than 72.5.
And
Okay.
do we need to talk about the T statistic at all, or just
Um,
more what you just said?
it's what I said.
Okay.
You don't know. Yeah. Okay. Calculate the standard errors for average life expectancies of Germany and Ireland, respectively. So if you go to the So what you can do is once you have this tidy data, you can filter it out for Germany and Japan. You can do Germany and then select Japan here and then copy paste their data. So life expectancy of Germany, you can take the data here and let's put a new sheet. And Japan, you can paste the right. So the question is asking standard errors for the average life expectancies of Germany and Ireland. Um, so again, for the average life expectancy, the standard error, you already have the standard deviation of the country, and so you can use that to calculate the standard error. So uh, you can either take the value from the summary here for the standard deviation. Um, for the country, it's already given here standard deviation for Germany and for Japan. Um, in the question here, so uh, if you want to calculate the sorry, what was it? Standard. Yeah, standard error. So, uh, you want to get the standard deviation of Germany. So you can go to this summary sheet, and from here you can look up Germany and take its standard deviation for life expectancy. Was This is your standard deviation for Germany and then divided by square root of 10 because Germany only has 10 observations. Um, and that would give you the standard error for Germany. And then similarly, you can do the same for Ireland. And then the standard error then is just the square root of the addition of both of them. So once you have these two values of standard error, you can add them up and take a square root, and that would give you the pooled standard error. So this is your pooled standard error. And then the null hypothesis, the question asks, we are interested in seeing whether Ireland's average life expectancy for the last 10 years is greater than Germany's. So write the null hypothesis, alternative hypotheses. So in this case, our null hypothesis is that the average life expectancy of Ireland is same as Germany. And the alternative is that average life expectancy of Ireland is statistically larger than the average life expectancy of Germany. So then you would do the same thing. It's a one-tailed test again, and you have the data here. So just go to the tool back and to assuming equal variances. So your first range is the Germany life expectancy, and then your second range is Japan's life expectancy, and the hypothesis I mean, sorry, Japan or Ireland? Ireland, sorry, not Japan. Oh, wait. I think I copy pasted the wrong values. It's supposed to be Ireland here. Sorry. My bad. Not Japan. So you can take the values for Ireland here, copy. Right. So then you open the tool pack and equal variances. The first variable is Germany's. The second variable is Ireland's. And hypothesis, I mean difference is 0. And then output, let's put it here. And so, yeah, so you have Ireland and Germany, and then the tail, one tail test p value is less than 0.05. So you would reject the null hypothesis and you would accept the alternative hypothesis. And you would say that, and then you would also look at the value of the t, t stat. So it has a negative value, which means that yes, Ireland's mean is higher because if it was a positive value, then Ireland's mean would be lower than Germany, and it would satisfy the other T-tail test on the lower side that Ireland's mean is lower. But our question asks if it is higher. So you also have to look at the sign of the T-tail. So you look at these two different means that are given here, and you see Ireland is higher and the T stat is negative, which means that Ireland's is higher than Germany. Uh,
Question, I think when I practiced this, I got the same p values and the same t statistic, but it was positive. I think I accidentally like put Ireland.
yeah, that's fine.
As
So
long as the explanation is still.
yes, yeah. So if Ireland is first, then your T stat would need to be positive if Ireland's mean has to be higher than Germany.
Okay.
But if Germany is first, then the T stat is yeah. So it's going to be flat. Yeah. Okay. What else? So we've done that, and then chi-square test. So create two new categorical variables from the data in question 2A. So it was the delete all these sheets. Average of GDP. Yeah. So we have this data. Oh, sorry. We have this data of life expectancy and average of GDP. So I've already copy pasted it. The average of GDP, and you can just copy paste the data from the summary for all the variables of GDP and life expectancy, and just hide all the unnecessary variables. Um, right? And then what you need to do is create two new columns, high or low GDP and high or low life expectancy, right? And for that you use an if formula. So if the GDP of this country is, wait, sorry. So the formula is if the GDP of this country, value of GDP, the hell, is higher than the average GDP, which should be here at the end, then say high, otherwise say low, right? So it's going to, so this GDP, 19 billion for Afghanistan is much lower than the average for 80 billion or whatever it is. So it will characterize that it as low. And you just copy paste all this all the way down till um hmm, what did it read? Oh, so you want to keep this D199 constant, right? So you put these $2 signs and then you can drag and drop it. And this time it will be fine. All the way here. And then you do the same thing for the life expectancy. So now you have two variables and telling the countries which have high GDP and which have low GDP, and countries which have high life expectancy and low life expectancy. So once you have that, um, you can then create, so you can copy paste this data here. And I have the data here. So just pulling this data here. Uh, where did that sheet go? Yeah. So the sheet here, so you can just pull the countries and then this high or low GDP and high or low life expectancy. Um, so I have this copy pasted here. So once you have this data here, you can create a pivot table to give you this matrix that how many countries have both high GDP and high life expectancy, how many countries have both low GDP and low life expectancy. And so you can select this data and insert pivot table and existing worksheet, and then let's put it here. So once you have that, what you can do is you can select, we want the GDP in our rows and then life expectancy in our values. Oh, sorry, no, in our columns, and then life expectancy as rows. So this will give you the matrix. Um, Actually, let's reverse these. Yeah. Yeah. So you have this matrix now, where a life expectancy is in the columns, and then the GDP is in the row. Sorry, life expectancy is in the rows, and the GDP is in the column. Um, And now, so you once you have this matrix, now you can do a chi-square test from it. So you take this matrix here, Um, what? Oh yeah. So once you have this matrix here, uh, you can calculate the expected values. So the formula for expected values is basically these. You take the value in this row. Uh, where's hold on. Sorry, what's the formula? Just forgot. Oh yeah. So for the expected values, the formula is you multiply the row totals of these two row totals. So if you have the value here in low, if you're calculating the expected for these low values, both low, you take the row total of this in whatever row that value is and multiply that with the total of the column in which it is and divide that by the grand total. So in this case, it would be 168 multiplied by 82 and that divided by 197. So you do that for all these four. So you get the expected values. And then once you get the expected values, then you can create the T statistic table. And the T statistic table formula is observed minus expected square divided by expected. So in this case, your observed is this 78, expected is 69.92, and you take a square of that and divide it by expected. So in this case, um, observed is 78 minus expected is 69, and you take a square of this all and then divide it by the expected. Wait, did I make a mistake? I didn't divide it, sorry. Yeah. So once you get that, you'll get these values, and you can repeat it for. So again, the T statistics value is the observed minus expected square divided by expected. So once you have this, you can get the chi-square value by summing all of these values up. So the sum of this is chi-square value. So this is essentially just the sum of all these values is the chi-square. And the degrees of freedom is the number of choices in a category minus one. And so we have two categories here. Life expectancy, it has two choices. So two minus one. And then GDP is another category, and it has two choices. So 2 minus 1 into 2 minus 1 is basically 1 into 1. So that is your degrees of freedom, 2 minus 1 into 2 minus 1. And so once you get that, then you can calculate your theoretical chi-square. And the formula for that is basically chi-square distribution. And it takes three inputs. The first is your actual chi-square that you calculated, and the degree of freedom. And then for cumulative, you do true. You want it, and so that is going to give you the chi-square. And since our chi-square theoretical is lower than the actual, so what would happen in that case? Can someone tell? When the theoretical is lower than the actual.
You, you accept the null hypothesis?
Um, yes. So you reject the null hypothesis in that case.
Theoretical is less.
Sorry, you accept the null hypothesis, and so yeah, so your um you say that there's a statistically significant relationship between the wait, no, no, I'm confused. Do you accept or do you reject? Uh, oh yeah, you reject the null hypothesis because your p-value is much lower. Yeah, sorry. You reject the null hypothesis and you say that there is a statistically significant relationship between the two variables. Because the null hypothesis says that there's no relationship between the two variables.
So then if it was, the theoretical was greater than the chi-square value, then it would be used.
Yeah, you would accept the null.
the-
Yeah, you would not accept the null hypothesis. Uh, Yeah, so and then the other, you can do the same thing. You can find the p-value here. So chi-square, you can use the formula for that, which is um, chi-square test. But for that, you have to give it two inputs. The first is you have to give it the this observed actual range and then expected range. And it's going to give you the p-value in this case. So here, this is the p-value. So always remember, like when you're using the chi-square distribution, it's going to give you actual chi-square value. And when you're doing the chi-square to test, it's going to give you the p-value. So p-value is less than 0.05. So you reject the null hypothesis and you accept the alternative hypothesis, which says that there is a significant relationship between the two variables. Uh, okay, yeah. So any questions? All good. I I think there's one other part which is the regression. I would just request if you guys can watch the recording on that. Yeah, I have the recording. I just need to be somewhere else.
It's fine.
Yeah.
I think it was this. I don't know why, but it's like, it has something now, but it's all done and it's very important for the next two weeks. So.
Because I think you didn't because you didn't route it. What about? So now even though it's showing it's down here, but you see the value.
Yeah.
So you need to press round
Okay.
because that's why we routed it because then like there's infinite values that. So that's what.
Thank you. So really quickly, for the question 6, how do you make the R squared value show up after you run the regression?
Oh, okay. Wait, let
I
me.
did that, and then for some reason I